Let's get to the next one. How about Eric Weinstein's geometric unity? What are your thoughts on that?
Eric Weinstein. Okay, geometric unity. That's where he's got a triangle that has the Dirac equation, spinors, and spin 1.5 matter particles on one vertex. And on another vertex, he's got general relativity, and on the other vertex, he's got the standard model with SU3 times SU2 times SU1 gauged it. Right? Okay. I think that Eric is actually, he seems like a very bright guy. I remember when he had I think, isn't he the guy who had the mathematics encyclopedia up for a long time on the web? I think it was Eric Weinstein. Just some guy named Eric Weinstein had a math encyclopedia up on the web. And, it's pretty impenetrable. I mean, if you didn't already know the math, you weren't going to get anything out of this encyclopedia. But nevertheless, it was good. But anyway, here's the strength of his approach, this geometric unity. Basically, he seems to be saying, it sort of occurs to me that what he's saying is, well, we're having a hard time putting together a TOE, a purely analytic algebraic TOE. So let's look at the geometry of these theories, of the Dirac equation and the standard model and general relativity, and let's see if we can put those geometries together. And if we can merge those geometries, then guess what? We're going to automatically just be able to match it with a global formal theory coupled with the geometry. Okay? And it's really kind of an innovative way to approach it. However, it's the way I've been approaching it for decades. The CTMU is logico-geometry. It's a coupling of logic and geometry, but it's generative geometry. Okay, which is a fundamentally different kind than what I think Eric Weinstein is dealing with.
Stephen Wolfram's theory of everything, the Wolfram project. What are your opinions on that? Have you taken a look?
Stephen Wolfram, he's obviously a very bright guy. He knows a lot about mathematics. He's kind of an adorable character. The way what it seems to me that he's done is he's tried to identify certain basic elements and rules of assembly, and then, like a bunch of tinker toys, he's trying to assemble those into the overall structure of reality. And I appreciate that, and it's entertaining to read Stephen's writing about it, and there's a lot of insight there, but it doesn't work, because if you're going to have a theory of everything, you need to start with everything. All right? You're not going to take a subset of everything and then put it together and get something which is reality, which is more than the sum of its parts. You're not going to do it. You've got to start with everything, which means you've got to start with cognition and perception in general. You've got to logically induce your theory from that. Okay? And that's the way to build a theory. But as far as Stephen's writing is concerned and the other aspects of what Stephen does, I think he's a very bright guy. I get a big kick out of reading what he writes. But this is more or less right up front for me. The fact that he's going about it in the wrong way. He hasn't seen the big picture. He doesn't understand all of the criteria that have to be satisfied in order to have a TOE. That's where you got to start. You got to start with everything. Nothing can be excluded, either implicitly or explicitly. You've got to have everything. You've got to have everything condensed or encapsulated somehow in some kind of process. And for us human beings, the process is cognition and perception. You start with those, and then you build your reality on it.
What about Donald Hoffman? Have you taken a look at his theories on consciousness and conscious agents interacting and so on?
Yes, I did. I think I watched a video with him and Deepak Chopra, and at one time, and I found him interesting. He's saying that basically cognition is deceptive. It's a cognitive scientist, as I recall. He's saying that some aspects of how we see the world is actually quite deceptive, but adaptive. In other words, it helps us adapt and survive to the world if we actually don't see it correctly. He's got this idea of a kind of a graphic user interface that actually allows us to have cognition that is deceptive, but nevertheless adaptive. And basically what Donald needs is he needs an overall framework in which to insert his GUI, his graphic user interface. He needs the actual reality self-simulation principle to make that work. He's a guy who is very much in need of a CTMU. Of course, he's an academic, so he probably would insist that it come from another academic. But if that were to happen, it would be called plagiarism. So I doubt that he's ever going to get to the true heart of things, get really where he's trying to go, simply because I'm not a member of the club in which he belongs and in which all of this stuff comes to light.
Okay, how about David Bohm? So how your theory compares and contrasts with David Bohm's theories, which I would like you to explain implicate order to me because I haven't had the chance to look it up. And then there's someone named Henry Bergson, which is related to Bohm. Now, I'm not sure how they differ, but you can elucidate me and the audience at the same time.
So Bergson is he's a great philosopher. He's one of the best. And as a matter of fact, some of what he had to say about manifolds I find quite interesting because it very closely parallels what has to be done in what had to be done in the CTMU, creating the medium of reality. As far as David Bohm is concerned, his reputation precedes him. There was an early Bohm and a late Bohm. The early Bohm was Bohmian mechanics, and then later on he came up with something called the holo movements, the holographic universe. I think he wrote a book on the holographic universe with Vasil Hiley. Yeah, it's Vasil Hiley. Anyway, he has this thing that he calls the holo movement that basically takes an implicate order and kicks out an explicate. That is pure CTMU. Okay, this is that process is what the CTMU calls involution. It's one of, just one aspect of the CTMU, but that aspect he actually captured very well with that holo movement, implicate and explicate order thing that he's doing with later Bohm. As far as the earlier Bohmian mechanics is concerned, that's dicey. Hard to make that work.
Would the implicate order be associated with descriptive containment and then the explicit is topological containment, or there's no relation?
Explicate order is the display, the terminal display, called the CTMU semi-language LO, and the other part is the CTMU semi-language LS, which corresponds to the processor instead of the display. That's the implicate part, okay? It's implicated, it's in implicate form there in a processor where things are actually getting non-locally combined and entangled, and telons are working to actually determine overall causal patterns. That's where that's occurring. It's all extremely, it's very, very interesting. Bohm actually matured as a thinker a very great deal in the course of his life. There are a couple of things I don't like, I think Bohm was a communist, wasn't he?
Right, and that may be one of the reasons why Bohmian mechanics came out of favor, because it was as if you were supporting communism.
Right. Well, Marxism is a very bad theory of philosophy. It's got a lot of holes in it. It's just awful in certain respects. So when you see a brilliant thinker like David Bohm grabbing a hold of it and embracing it, this can't help his reputation. You see, and I think Bohm suffered a great deal because of that, but you can certainly understand why it happened. Yeah. As far as Bohmian mechanics is concerned, he's basically trying to concretize everything. He's got a pilot field, that is actually, he's got the Schrödinger equation, but he's also got this, the pilot field is actually guiding the particle to its destination. But what is guiding the pilot field itself? There are a number of philosophical questions that could be asked about Bohm's theory that reveal that it is indelibly associated with the terminal side of the reality self-simulation. So in other words, it's terminally confined in CTMU terminology, which means that it's not really any kind of complete interpretation of quantum mechanics.
I've been told I need to learn more about Bohmian mechanics and Bergson if I'm going to be investigating theories of everything.
A lot of people really like Bohmian mechanics because of its strong points. and it does have strong elements, but it won't really do in a theory of everything. If a theory of everything relies on Bohmian mechanics, it's toast. Because there's just not enough there to pull it off. As far as Bergson is concerned, it's like I say, a fine philosopher.
Okay, how about Douglas Hofstadter's strange loop idea of consciousness? You know, Gödel, Escher, Bach, I'm sure you've heard of that book.
Yes, yeah. I think I was probably in my early 20s when I got a copy of that book. The strange loops, pushing and the popping and all that stuff. Quite an intriguing book. Very much in fashion for a long time. Sort of a precursor to the reality self-simulation, in some ways. But yeah, Hofstadter was definitely an intellect worthy of respect.
People ask me, who do I want to interview most? Douglas Hofstadter's up there, Penrose is up there, and even Eminem.
Roger Penrose is really into that.
Where do you see Douglas Hofstadter's theory lacking, and what do you like most about it? So what dislikes, and then like pros, then cons.
Well, he relies a lot on computational principles, and I think he might be, nevertheless, even though he's relying on a lot of advanced logic and, towers of meta languages and levels of computation and so forth, he shows no sign of being anything but a physicalist in the sense that it's all computational, and computation is a mechanical process. So it looks to me like it might be like his outlook may be basically mechanistic.
Right.
Right. Which, I can't agree with, because that's not what reality is. And CTNU.
Now, Penrose seems to agree with you in saying that there are many paradoxes associated with thinking that consciousness comes from something that's computational. Have you heard much about Penrose's theory of orchestrated objective reduction and so on with Hameroff?
Yeah. Hameroff is on a lot of these, or at least was on one time on a lot of these distributions that I found myself on occasionally. And, there is something to it. I mean, Hameroff identified microtubules, cytoskeletons, right, as being a place where quantum coherence might actually be able to function in the brain. And there are other ways that quantum mechanics can insert itself into neural processes as well. But of course, he relies on Penrose for most of the physics and actually, figuring out where it's all coming from. And Penrose has this idea of a Platonic realm, or, this Platonic form of reality. It's a tripartite form of reality. There's these mathematical truths that exist as, these fully formed mathematical objects in Platonic realm. And, he doesn't have the CTMU. Roger Penrose doesn't have a fully formed theory of reality, but he's just very hard not to appreciate because he's so brilliant. I mean, the guy can, it's just, his brilliance will almost floor you sometimes when you read some of the things that he writes. Mathematically, he's a brilliant mathematician. He's a brilliant physicist. And, this idea of his that basically, it's not just computation, that there's something that is undecidable going on in human thought, that basically, what Gödel theory implies. He says you've got a system, there's certain, a system that actually is capable of transfinite induction and is truly interesting, can actually, there are truths that cannot be derived from any finite set of axioms in such a system. Okay, so basically what Penrose is saying, he's saying that human thought somehow generates undecidable theorems that are true on a metamathematical level, but cannot be derived from any theory. This is exactly what the CTNU says. I started publishing in the same year, I think. He came out with a book. I think his biggest theoretical statement was The Emperor's New Mind. Recognize that title?
That's correct.
Okay. That was 1989, which is when I wrote The Resolution of Newton's Paradox. So we started publishing at about the same time. He got a hell of a lot farther than I did in that amount of time. But then again, he wasn't canceled. Teaching at Oxford, does a very great deal for you when it comes to disseminating your work.
How about Thomas Campbell and his My Big Toe? Have you heard of that?
I've heard of my big toe, but let me defer to you. You probably know more about it than I do. What does it say exactly?
It's a strange theory, essentially that there's another realm. When you mention that there are that there are data points that come to us instantaneously in this non-terminal realm, Thomas Campbell also says that that's the mechanism by which psychic phenomenon work, that it occurs to you instantaneously. We think that it has to travel some distance in the same way that it would have to travel in our space-time, and there's a finite speed. He says no, that this other realm where consciousness operates is...
Well, that sounds very CTM.
He also has Aum. He calls it Aum, which you call unbounded telesis. He has Aum, unbounded absolute oneness, or absolute unbounded oneness.
Is that supposed to sound like Om?
No, as far as I know, it's a coincidence. Anyway, he says that that's the fundamental constituents, this place of complete potential.
Yes, that's CTMU consistent. Yes.
Although he says this, which I disagree. He says that unrealized potential is trying to do is to create order and to decrease its entropy. And I quibbled with him because I don't think that order and entropy are what people claim in common parlance. Entropy and order and disorder are not actually... High entropy doesn't mean low order in the way that most people think. And it's obvious because if you look at a coffee cup with some milk and you create some turbulence, that looks completely disordered. And then when you stir it, then it looks uniform, it looks ordered, but that actually has the highest entropy. So
you've seen those little machines where you turn the crank and these two, these seemingly chaotic patterns are created between two differently colored gelatinous liquids. But then when you turn it in the other crank in the other direction, it's restored to a complete state of separation.
That sounds like Maxwell's demon.
It's amazing to watch.
That's Thomas Campbell's.
Okay, well,
it reminds me of yours, though. Yours is more rigorous.
Yeah. I mean, mine actually has structure, mathematical structure to it. But it sounds like he's coming up with some good ideas that are on the right track and can be successfully interpreted in a true theory of everything.
He also had out-of-body experiences, and he would suggest that people who are younger are more in tune, or more naturally in tune, like you get out of tune as you get older, with this other realm. And so you can go, and what you think of as thought space is actually a real space, but it's another space. It's I wouldn't use the word dimension, but it's another realm, let's say, a primordial realm.
Right. It's another terminal realm. Like I say, that's always a possibility. You can create terminal realms that are not identical to physical reality, and that may be related more or less tenuously to it, but aren't dependent.
If you enjoyed this toe clipping, then the full video is linked in the description. You should also sign up for Toe Mail, which is again in the description and the pinned comment. You'll receive immediate access to all exclusive updates from the Theories of Everything podcast. It also helps me communicate directly with the core toe community. You'll also receive my top 10 toes. Think of it as the intellectual version of Quentin Tarantino's Obsession.